Yeah, thank you so much to my awesome two MCs. As I already mentioned, my talk will be about Ivy. Who of you ever heard about Ivy? Like, awesome. And who have ever already used it somehow? Ah, that's good. Today I'm gonna introduce you a little bit more deeper into Ivy, like why you should actually already use it, even though it's already right now opt-in, it's not there by default, but I will dig to that deeper during my talk. First to me, as Juan already said, I'm a GDE at Web Development and Angular, a fresh baked actually. I'm also a woman tech maker group leader in the south of Germany. I'm from Heidelberg, so I'm organizing in Karlsruhe and Heidelberg, the women tech maker group. And I'm a trainer. I'm doing Angular workshop in my free time. And I'm co-organizing anti-girls workshop. Like yesterday, there was one. We had 70 girls, actually, and 15 mentors, and this is so amazing. Some of the mentors are actually here. I'm really, really happy and glad for them to be here. And I'm also organizing the Angular Heidelberg meetup, because I'm in Heidelberg, and I love Angular, and I have too much free time sometimes. Whenever you want, ping me on Twitter or just reach out on me on my webpage. There are a lot more contact details if you have any kind of questions about Angular or Ivy. So what I'm going to talk today is about why there was a decision at all in the first place for a new engine. I mean, we had already an engine change from 2 to 4, so why was there a need after all? Then how? I mean, everyone is telling you, now you use Ivy, and with Ivy, everything will get better, but why? And how does it actually work? And how can you use, nowadays, in our projects, actually Angular Ivy? And unfortunately, cheers to Kamil, who brought me to this idea. You will get to him later, too. There will be a lot of cat content during my presentation, so I'm sorry for that. But cats are one of the best animals in the world, obviously. So first, the question, why do we need a new renderer engine? I mean, we had already one, the Vue engine, the one before. So actually, we had a template engine till Angular 2, then the Vue engine, and now there was a change. Like now with Angular 8, there came something that's called Angular Ivy, and now you hear something like, oh, we might not need engine models anymore at all. And there is a great talk later by Eliran. I highly recommend to watch this talk. He will tell you how you can remove or how you can develop with Ivy that you don't need engine models anymore. This is a great follow-up talk about mine. So why do we need a new rendering engine? So what is the most costliest resources on a web page? You might think HTML, you might think CSS, but as we know, we have so many single-page applications. Of course, it's JavaScript. Back in the days with the template engine and Vue engine, it was megabytes of JavaScript code that we actually had to ship to the web browsers. There were like persons with smartphones that are somewhere with like so-called low network devices who had long and tons of JavaScript to download actually. And this is one of the biggest issues Angular had back then or still has. And the team is really right now making this better and really developing to helping this. So that's why they decided, okay, we need to create a new rendering engine. We need to create something new that creates a smaller bundle size. So the first steps actually, and I don't know if you ever heard of the cake threshold, there was Brad Green who led the team and said, okay, we need to create a rendering engine that actually reduces the bundle size. So currently, today, it's just a Hello World, like engine new and a Hello World example. It's about 36 kilobytes. Of course, it's nothing in comparison to our real-world examples. But he said, okay, ladies and gentlemen, if you are able to create a rendering engine that creates a bundle size below 10 kilobytes, I will get you all the cake. And so the cake threshold was born. And actually, they did, and they did a really great job on that. So the team announced that they then finally reached 7.3 kilobytes with Ivy minified and then compressed even 2.7, and this is amazing in comparison to the 36 kilobytes we have nowadays. So unfortunately, I wanted to show you a picture, I didn't find it, where Brad Green actually bought tons of cake for all the team, and they really enjoyed it, and they really did a great job. So with Ivy comes some other benefits I want to show you today. Of course, a smaller bundle size, faster compilation, and easier to debug. So these are the main 3 benefits you will get if you use Ivy today. So let's dig into that. How are we doing that? So first of all, we will focus on how we can create smaller bundle sizes. For that, we have to take a look in how the Vue engine is doing it currently. So if you ever heard of that, of course, every single day you will create a cat component for obvious reasons. And then when you compile it, actually build it, then you get 2 files out of that, a cat component JS file and a cat component ngFactory JavaScript file. So the cat component is actually your compiled TS code. And the ngFactory file is a static representation of your template code, the HTML code you actually wrote inside a component. So this means as well there has been a mapping between 2 files together. Of course, it will be minified and compromised afterwards, but there is still a mapping between 2 files, which automatically means a longer building time as well. So what the team thought, yeah, we just removed that. We don't need it anymore, so we just have the cat component and we are happy. And we just have the 1 JavaScript file and we are happy. Of course, it's not like that easy, but what they actually really decided was to move the template code inside JavaScript, the static representation of the template code. They put inside the normal JavaScript file as well. So first of all, you do not need a static representation of it anymore, like of the template. Like the ngFactory file, I mean, you still have here static representation. It can be found here, template function. That is the function that is called, that creates actually then your component. And of course, they introduced something that is called a static definer. Means this define component there in the beginning. So every single time when you see an add component or add injector, it will now be compiled to a define component or define injector, where things are written down, like the function, the metadata, selectors, and some other metadata about the whole component. So by knowing this, we now will face the question, how do we make things actually smaller? Of course, obvious. Don't ship something into the web browser you don't need. The keyword is here, of course, tree shaking. So tree shaking basically means that there is a function somewhere in your framework, or you wrote a function, and you don't call it. You don't use it in your complete stack trace at all. So why do you have to actually ship this to the web browser if nothing calls this function? And here's the point, because the Vue engine isn't tree shakeable. That means the whole Vue engine, the Angular that's compiled Vue engine is really big because it ships so many functions and code that you might not use, but it's still there. But why is it like that? So first we have to go again how the Vue engine is actually compiling the template code. So it creates, and this is now inside the ngFactory file, it creates something that's called a Vue def. It's an array of instructions. So you can see here we have a div, hello ngde, and there you can see there is something like an element ref that has all the information about the div over there. The div has a class, and the class is blue, because blue is the best color in the world, and obviously, and there's a text def, and the text definition says, okay, inside this div, there is a hello world ng. There's a hello world, there's a hello ngde string inside. There are a couple of other parameters, but we don't have to get bothered by that. So far, so good. The issue about that is that during now the compilation time, the framework now iterates to every single component and creates the so-called view nodes. So what we see here actually, it's exactly from the Angular framework compiled by View Engine. It goes through some switch cases. So if I removed some stuff not to get too much confused here. So it basically says, okay, when there is an element ref inside this array, then I have to create an element. Okay, when I create a text, when there is an element definition for text node, then I have to create a text node, and for pipelines, and for more as well. So, of course, the representation is an integer, just to let you know. But what is the issue over here? With this approach, actually, the framework or the compiler can't know during static analysis and runtime if a function is called or not. And for that, it can be removed out of the framework. And this is the biggest issue. This is one of the problems the current View engine has. So, of course, you don't create just components who looks like that. Of course, they are bigger. But let's just say you don't write a pipe on your own, but the code to create a pipe, it will be still shipped. So, of course, maybe it's just some line of codes, but it's unused, dead code, and it's better to tree shake that, of course. So this is the main point why Ivy now is so much smaller. But how is Ivy now doing that? So take a look about that. Actually, we remember I told you about the function, that this template function, it now creates the complete JavaScript code for the template, for the HTML part. So what is inside this function is actually function calls, okay, here I want to create an element, and here I want to create a text. So it's not like that the framework is iterating through every single component. It's more like that the component itself calls the function in the Angular framework. And just because of this, of course, we can tell if, for example, a pipe function, to create a pipe function, would be needed or not. And if it's not needed, we can just remove, we can just reshake it out of it. We can just shake it off. Yes, so it's more that the component definition calls the framework and not the other way around. And this is one of the main key points why Ivy, when you ship Ivy by itself, it's reduced the bundle size so much. So it basically looks like that. And here you can see that we have the function calls directly, element start, the text node, the template by itself. This, maybe you already have seen this, I don't even know right now, I don't remember the name of the sign. What? Zeta, what? Delta. Ah, you're right, exactly, thank you. This delta sign over there, it means it's a private API from the framework itself. So it's a function inside the Angular Ivy framework. So here you can see on the first, if the component gets first rendered, then it will create all this and 2 element nodes over here, a text node, and then it's done. And now for this, we can remove all, as I said, all the pipe creation functions, because we know exactly what we need and we know exactly what will be called. This is quite amazing, in my opinion. So the next point I want to talk about is the faster compilation. It's not only about, we all know that sometimes it feels like you download the half of the internet when you run npm-e, but sometimes as well it's like when you run ng-build, you have to recompile everything again. But why is that so? And I want to tell you as well why Ivy does it now in a more improved way. So here's something new. So generally, a component has all the information about all the dependencies of itself. So if there is, for example, a directive like ngIf or ngFor, the component knows as well what ngIf needs to be compiled. And then this needs to know what we compiled, and so on. There's a whole chain that needs to be compiled every single time again and again. But just because maybe the constructor or the dependencies of ngIf changes, all the components that uses an ngIf needs to be recompiled as well. So there was a thinking, and it's so-called locality principle, that we just have a single file compilation. So we just tell, okay, this component, it has an ngIf by default, but why do the component need to know what the dependency of the ngIf is? Or maybe you write your own structural directive. So there's no point of doing that and of knowing that. And so thought the Angular team as well. So they created something that is so-called a single file compilation. So if a component got recompiled, nothing else needs to be recompiled as well. So this is a view engine example that the view engine knows now here at the ngIf exactly the dependencies of ngIf. But the component is using this ngIf, as I said, but it doesn't need to know the dependencies of an ngIf. So what they did, the Ivy way again, is the same snippet actually we thought before. But now here in the end, we see, yes, we need an ngIf, and then we call the constructor of the ngIf, which then knows exactly, with the help of this new static definition, here is the defined directive static definition, what are the actual dependencies this ngIf needs. So this means as well, a step further, that we actually can already third-party libraries precompile them, and Ivy offers this possibility, precompile them with AOT and shift it through NPM to your package. The component itself knows exactly what it needs and can be compiled completely alone and with AOT. So easier to debug. Actually, I wanted to show you, but maybe live coding is always a little bit tricky and difficult. I just wanted to tell you that with this clearer API, and additionally that we can now have this function call to the framework, we know now we don't have to debug through the framework itself. We can directly debug on the component, because the component calls the function directly. With that, we have a lot of more possibilities to actually debug through our code and find the mistake. So far, so good. Everything fine. Now, finally, how can we use it nowadays in our project? As I said, Angular Ivy in version 8 is now opt-in currently. So if you want to use it, you have to make a flag, enable Ivy, and then build it. And then you will, and then you can actually already compare these two bundles with each other. Of course, when you just have something like a Hello World example, it might not make that much difference. But if you have a bigger project, a real-time project, you will definitely see the difference. And I highly recommend you to try it out on your projects, since the Ivy will be enabled by default on version 9. It is right now dated on the Q4 this year. So then the default option is Ivy. And the whole team is right now working on it to have the best experience for you as well. And if you already adapt it and include it in your project, you can even file an issue if you find something, and you can help the team to improve Ivy even more. If you already have a project that actually was first set up and built up with the Vue engine, you can just go inside the config.json and actually set this flag by your own. Actually, when you run a new project with ng-new, enable Ivy, then this flag will be set for you automatically. You can also remove it and add it, and it works actually. So I rushed a little bit through it, I recognize, but what we learned is why Ivy is so awesome, why you should use it, like that we now have finally a renderer engine that actually reduces the bundle size really significantly, since the framework itself is now tree-shakeable. It recompiles everything faster, since components and other parts of your Angular project actually already, when they're already compiled, they don't need to be recompiled again anymore, because it only recompiles that what actually changes. For example, it doesn't need to recompile your whole Angular material library stuff anymore. And maybe, as you know, there are a lot of Angular material components and models to import. Yeah, so I actually reached already my end. Thank you so much for listening to me, for being here. And if you want to know more about Ivy, just feel free. I'm here for the next 2 days as an organizer. Maybe I'm running around a lot, but just reach out for me and ask me for any kind of information about Ivy.